Hello and welcome to Northgate High School's Design and Technology Department. My name is Mr. Day and I am the Head of Design Technology. I'm going to talk you through the Year 12 Product Design course today and try and explain to you a little bit about its structure, how we view it at Northgate, show you some past examples of students' work and talk to you about some things you can do in the future to try and progress your knowledge and skills in this area. Northgate High School has a purpose-built design and technology block. This is the building in front of you that houses it. If you walk down the left-hand side of the building, you will see a small doorway with D&T above it, and as you enter it, you will come into our reception area. You will then see 4 rooms that are purpose-built for different aspects of design technology. And for those people that have not been to Northgate before, I'm just going to talk you through what they house. Our first room is T29. This is a traditional woodworking workshop. We have a woodworking lathe on the left there, 2 pillar drills, and between them we have a mortiser. Towards the back of the room on the left hand side is our hardwood store, and on the right hand side is our softwood store where we have a circular saw, planer thicknesser and 360-degree chop saw. We also have a single center lathe in here. We have 3 Hegner jigsaws and 2 disc sanders, and this is a very wide open space, and we tend to use it also for an awful lot of handheld woodworking tools such as routers and biscuit cutters. Our second room is T30. This is a computer room and a desk room which has lots of space for design. We tend to use the computers in here, which there are 24 of, for Fusion 360 design work. T31 is our metalworking room. It has an aluminium casting set, 2 gas hearths. We also have welding equipment, which includes manual metal arc, MIG welding and gas welding. We have a Stark-Right bandsaw, another mortiser, 2 disc sanders, a series of different sized pillar drills, and then we have 4 center lathes. And just behind the camera is also a milling machine. A very well equipped metal working workshop. Again, desk space for us to do numerous items of work on. T32, our final room. Down behind those 2 white doors is where we house our laser cutter. We have 20 computers that we can use for design work, and we have large open desk space that we tend to use for theory. And just behind me again are a series of benches where we can construct models and continue with practical work. All of our workshops are very versatile and are well equipped. The A-level unit structure. The A-level is made up of 2 components. Component 1 is the theory that you need to understand and develop over the course of 2 years. We make an effort in the first year to teach this during 1 lesson a week, and we also reinforce it through practical lessons. The theory is made up of 12 different areas, and it starts off with traditional materials, hardwoods, softwoods, ferrous, non-ferrous metals, thermosetting plastics, smart materials, and very quickly progresses from that point into a wider sense of D&T. We look at mass manufacture, we look at rapid prototyping, 3D printing, we look at different philosophies behind the manufacture of products. We look at legislation such as British standards, European standards, copyright law. We look at modelling, how you manage the manufacturing process to make it efficient. We look at things like Scrum, which is to do with designing software. And then we go further into the sort of ultimate principles of manufacturing, which is what we call Lean Six Sigma. It's a very wide-ranging theory, and the theory work will lead you into a very, very good understanding for degree level study. The theory is tested at the end of the 2 years in an examination, and that is 50% of the qualification. The second part of the qualification is the independent design and make project, which we're going to have a look at in a bit more detail in a second. But it's basically your project that starts about a month after Easter, and you can literally design and make any product you like, as long as you consult us first and we agree that you've got the time and the funds to create it. And we're after people that are prepared to put in the work and the effort to create something that's outstanding. We're very keen to develop interesting aspects of work for our students. The Year 12 course starts off practically. Over the years we've done a number of projects, and they're designed to get students from all different classes, all different styles of D&T to the same point. We originally started off with an aluminium casting project and a little woodwork project, and now we've progressed a little bit further. This project is all about creating an aluminium mallet, and it is our current project for Year 12. We basically give you the drawing on the left hand side, and then we run you through the principles of how to construct the mallet using center lathes, pillar drills and other metalworking technology. It's a really good project for teaching students how to use that machinery, but at the same time work to quite a fine tolerance. We then ask students to create their own packaging for that particular product, and there's an example on the right hand side of a previous product that has been made. After that project, we do a design project, and again it's purely a sort of blue sky thinking design and model project. We don't actually make this one, and again over the years we've done a wide range of different topics. This year we looked at the sustainability of housing in the UK. We all know that housing is very expensive, and we kind of thought about, well, how could we make usable housing out of a product that is very basic but again very easy to make, and that was a shipping container. And our students were charged with designing and making products that were unique to this particular type of design. And here are a few examples of the models. Unfortunately we didn't get these quite finished due to the closure of the school due to COVID-19, but a very exciting project, some good model making skills, experienced working to scale, and thinking about how you can get a really basic shell-like structure and turn it into something that is useful and usable for the human environment. Just to give you an example of design work, as you can see, this is a past A2 piece of work. We asked people to design by hand initially. They have to produce a 3D isometric style design, and around that you have to support the design. You have to bring in elements of research, design influence, and use them to justify your design decisions. So in addition to using the isometric hand design skills, we also ask students to become proficient in Fusion 360, which is a piece of design software by Autodesk. Most universities use it, and certainly a large amount of employers do. And we think the more you know about it, the better your employability and career options are. So we teach it as part of the course, and we expect our students to develop their work involving it. Design work requires students to show development. As you can see, this design varies slightly from the first design, but again the principle's the same: isometric drawing, examples of how the design might go together, supported by research. That is then followed by a 3D CAD render. We're now going to have a look at some past examples of Year 13 final projects. We're going to look at the scope of work that students have produced. This was a solar powered fountain created by a lady who was very much interested in the sort of design for nature or naturalist design. She produced this item out of copper, and it's a very effective aesthetic product. A more traditional product here, Robert here created a bench. This was all produced in our forge by hand using chalk lines on the floor to match the components, and then it was welded together. He did that because his grandfather was a farrier and he wanted to have the same experience. A fantastic project. Dominic created a steam chair. The two legs that act as arms as well are basically laminate sections, so it's thin layers of hardwood that are glued together, and then a mortised frame is used for the base and the top section. Frankie went on to construct a guitar, quite a difficult task actually. We made the body for it and wired the electronics up, but the neck was a purchase product. Actually a very good example of something that requires huge amounts of precision to get a very, very good outcome from. Natalie was a student who was on the art spectrum as much as D&T, and she wanted to create a piece of furniture that linked her artwork to furniture that could be used outside. She went on to a career in civil engineering. Robert, he created a paddock stand and a rear wheel lifting stand for his motorbike. His motivation was the fact that he wanted more security for the motorbike, and he came up with these two pieces of metalwork to support his ideas. The quality of the products was extremely high. The product was shaped, cut using traditional hand tools, and then welded together. We used a plasma cutter to cut out of the shapes to reduce the weight. A very, very well made product that served its purpose accurately. Jonathan created this very large audio piece of equipment. He created the 4 boxes for the speaker units. They were created from 1mm thick plywood that was laminated to create a very strong shape around a frame, and then the reverb unit was housed in the same way, and it was a very, very good looking piece of equipment that worked very well. We don't offer an electrical A-level anymore, but you can combine electrical aspects into your design work. This product was made by Adam, and he wanted to solve a practical mechanical problem, and the problem was, how far can you throw a tennis ball? So he went through numerous different designs. He went through some basic engines, he went through different mechanisms, and in the end he came up with this sort of elastic powered launching mechanism, which proved to be his most successful outcome. Toby, he was very much into aesthetic products and wanted to go on and study architecture. He created this hardwood laminated clock that was built out of 3 components, could be assembled and disassembled quite easily. Very large piece of work, but a very elegant piece. This piece of work was created as a mixture of D&T and art, and it is an elastomer chair. As you sit in the elastomer strings, they take your body shape perfectly in terms of ergonomics and provide you with a very comfortable resting place. A very different concept from some of the others you've seen. James created a hardwood oak-based bench. This was created for his grandparents. The legs are created out of thin layers of oak that have been laminated into curves, and then a traditional mortise and tenon frame has been put together to match the style of the legs.
Hello, my name is Jamie Clements and I'm in Year 12. I decided to choose product design because I enjoyed the subject through GCSEs. I'm also interested in a career in engineering, as one of my favourite parts of the product design GCSE course was using CAD software.
Hello, my name is Gabby and I'm in Year 12. I chose DT as I enjoyed the subject in GCSE and would like to go into a career in the future with aspects of product design involved in it.
Hello, my name is Samantha and I'm in Year 12 and I previously studied at Westbourne Academy. I chose DT because I want to study architecture at university and DT is a requirement. Also, I like the idea of designing products and I love the GCSE art and design subject.
Hello, my name is Isaac and I'm in Year 12. I chose product design because I enjoy the subject and would like to pursue a career in engineering. I most enjoy the practical side of the subject.
I'm Tom, I'm in Year 12 and I chose A-level product design because I really enjoy the practical side of the subject and I want to do an engineering degree and I think that it will help prepare me for it. Also, the practical facilities at Northgate are also of a very high standard and you have a lot of opportunities to make high quality products.
Hi, my name's Daniel and I'm in year 12. I chose DT product design because beyond A levels, I hoped to have a career in aerodynamic engineering. At the moment, the dream is to work for McLaren F1 team. My favourite thing about DT is trying to come up with creative ways to fix problems.
Hello, my name is Lucy and I'm in year 12. I chose DT because I loved the course at GCSE and wanted to continue developing my skills and knowledge as I found it interesting. Also, an A-level in DT is recommended for many of the university courses I have looked into, so this puts me in a good position for the future.
Our final piece is, where does this course take you? Well, ultimately it probably takes you to degree study, but it's the foundation for many different aspects of engineering. You could be going into architecture, you could be going to materials, you could be interested in manufacturing, you could be going to product design, you may wish to go to medical equipment design. The world of engineering is wide and there are many opportunities within it. And this is the first fundamental step of the ladder to get into that HE education and to move through one of these routes. In addition to that, you could do a foundation degree, or you could go and get an apprenticeship, and you could then do an HNC, which is the Higher National Certificate or the Higher National Diplomas within a different field of engineering. This particular qualification is a really good fundamental foundation for moving on to have a technical career.